This is the second video for 4.5. We talk about the conjugates of complex zeros. So we have mentioned conjugates before when we were talking about imaginary numbers before. But they're really important when it comes to zeros because it always happens that if there is a number with an imaginary part, then its conjugate is also a zero. So when we say conjugate, we're changing the sign on the I. Okay? We don't change both signs. We just change the sign on the I. So the conjugate of 1 plus I would be 1 minus I. The conjugate of 2I would be negative 2I. The conjugate of negative 37 minus 5I, so the negative 37 stays the same, but now it'll be plus 5I. And negative 2 minus 3I, the negative 2 stays the same, and it would be plus 3I. Okay, so that's what we mean by a conjugate. It is not changing all the signs. It's not the opposite. And remember how when we multiply these conjugates together, it's the sum and difference. It gives us the difference of squares, right? That's the important thing that we get to here. So when we have a zero, remember x minus the zero gives us one of the factors. And if we didn't have the conjugate, then we would end up with imaginary parts in our coefficients. And so all of the polynomials that we're looking at have real numbers for their coefficients. So that means it has to be that every imaginary zero has its conjugate as a zero. So here's what happens when we take x minus the zero. And you notice that the one on I changes. The sign on I is different. But see, this sign with the I is different. This is the same. This is the same. The number in front of the 1 is the same. It's always x subtract the 0, right? So it's only the number on the I that changes. All right, so let's multiply these two factors out. It would be these would be factors of a polynomial. So we have x times x, that would be x squared. And let's just distribute this negative right now. So it's negative 1, and it would be negative I. And if I distributed this, it would be negative 1 plus I. Okay, so that's x squared, and then we have x times negative 1, that would be negative x. And then we have x times I, so that would be plus xi. Then we have negative 1 times x, so that would be negative x. Negative 1 times negative 1, that would be positive 1. Negative 1 times I, that would be negative I. And then negative I times x would be negative xi. And negative I times negative 1, that would be positive I. And then negative I times positive I. So it would be negative I squared. And I squared is negative 1. Right? Okay, so let's see what we have. Okay, so this xi, whoops, this xi and there's a negative xi, that's 0. And we have a negative I and a positive I, that would be 0. And so let's see, I have x squared, and then I have negative x and negative x, so that would be minus 2x. And I have 1, and this would be a plus 1, right? So that would be plus 2. Okay, so this polynomial with real numbers as the coefficients came from, it has two zeros, right? The two zeros are 1 minus I and 1 plus I. Okay, and it came from these factors up here that we used in order to get it. Okay, now this is a common thing that we're going to be asked to do, and that is I'll give you some zeros, and you have to find the polynomial that they came from. So here's an example of what you might see. Find a polynomial with zeros 3 and 2i. Now, when we say polynomial, we're going to assume it's a polynomial with real coefficients. Okay? And they probably would say a third degree polynomial. So I didn't write that in, but it probably would say find a third degree polynomial with zeros 3 and 2i. So the first thing you have to think about is, are there other zeros? I really want 3 zeros. Since this is an imaginary one, what do we have to use? We have to have the conjugate. So that means negative 2i is also a 0. Okay, so those are my 3 zeros. I'm doing a third degree polynomial. So that means my factors are x minus 3, x minus 2i, and x minus negative 2i, which would be plus 2i. Okay, so really that's my polynomial. It's in factored form, and usually what you're going to have to do is put it into general form, which would mean no factors, right? And also no imaginary parts. Okay, so to do that, I'm going to suggest we could do this in any order, right? We could multiplication is commutative and associative, so we could mix this up. We could do, these two first and then take that answer and multiply by the next one. But since we can do it in any order, I would suggest you do these two first. Okay, because once we do these two, we won't have any i's left in our answer. Okay, so I'll just bring down the x minus 3. We'll do that one next. So now I've got x squared, and I've got 2ix, and then I'll have negative 2ix, and then I'll have negative 2i times 2i, so that would be negative 4. I squared is negative 1. Okay, so I end up with x minus 3 and x squared. These two cancel, and this is plus 4. All right, then we multiply these out. We got x cubed, and we have plus 4x minus 3x squared and minus 12. Okay? Just really annoying. Okay, so probably would write it in order. Minus 3x squared plus 4x minus 12. Okay, so there is my polynomial. Now, I could tell you, find a third degree polynomial with these zeros that has a 24 as the constant. Okay? Well, I would look at this and say, oh, this isn't 24, right? This is only 12, or negative 24 is what I'd want. so in order to get to the number I want, I'm going to have to multiply my polynomial by 2. Okay, so we would say this whole polynomial multiplied by 2. That would give us a negative 24 on the constant. Now if I really did want positive 24, which is what I said, I'd have to multiply by negative 2. Okay? Now suppose I wanted a 3 for my constant. Well, in order to get a 3 for my constant, I have to divide by 4 or multiply by 1/4. Or since I want a positive 3, it would be negative 1/4. Right? So that would mean I would have a 1/4 here. And when I write my polynomial, I'd probably pull the 1/4 through. I'd have fractions for my coefficients, but that would be okay. And that would give me what I said I wanted for my constant. So that's what you have to keep in mind. You get your basic polynomial with these zeros. If they tell you to find something specific about one of the numbers, then you multiply by whatever you need to multiply by so that you get that specific number. We'll do one more. I'm not going to multiply it all out this time, but we'll just write down the factors. This time I want a 5th degree polynomial with these zeros. So the ones that are imaginary, we have to have a conjugate with them, right? So if 2 minus I is a 0, then 2 plus I is also 0. If 3i is a 0, then negative 3i is also 0. My polynomial would be x minus, remember it's always x minus the 0, right? 2 plus I, because I distribute that negative, x minus 2 minus I, x minus 1, x minus 3i, and x minus a negative 3i, which would be plus 3i. Okay, if we wanted to multiply this out, we could, and we would get some nice 5th degree polynomial. And when you did that, if you were going to do that out, multiply these together first, and multiply these together, and then the other ones, it wouldn't matter the order that you did them in. After you do those, you'll have 3 polynomials with no imaginary parts. Alright, here's your quiz question. You got to find this pretty easy. Find the conjugate for the complex number, negative 3 minus 5i, and go enter this into Canvas. Don't put any spaces in your number, and that will help you get it right.